In this video, we'll be learning about GraphQL and how it works under the hood. We'll learn how it's different from REST and whether we should prefer it over REST APIs. After that, we'll learn how to use GraphQL with NestJS. We'll make queries and mutations to get and change data. But before we jump in, let's quickly understand what is GraphQL. GraphQL is a query language for API and a runtime for executing those queries. Unlike REST, where we typically have fixed endpoints returning fixed data structures, GraphQL allows clients to request only the data they need, in the shape they need it, all in a single request. Now let's understand how GraphQL is different from REST. Suppose we have a REST API for a blog. To get information about a blog post, we might have endpoints like post and users, each returning different pieces of information. Now, as we learned previously, in REST, we have fixed endpoints that returns fixed data structures, which could lead to overfetching or underfetching of data when data becomes more complex. Overfetching occurs when the API provides more data than what is needed for a particular use case. This results in unnecessary bandwidth usage and increased response times. For instance, if we only need the name and email of a user, but API sends additional data along with it, it's considered overfetching. On the other hand, underfetching is when the API endpoint doesn't provide enough data in a single request, forcing the client to make additional requests to fetch the required information. For example, we want to fetch users' data along with all the blog posts they have published. Now at user level, we only store blog post IDs, so we might need an additional call to get blog post information. With GraphQL, we can easily resolve these issues. A client can request exactly the data they need in a single query, which will eventually resolve the number of requests needed. GraphQL works by defining a schema that outlines the available data types and their relationships. A schema is a collection of GraphQL types. GraphQL uses it to describe the shape of your available data. When a client sends a query to the server, it's parsed and executed by resolver functions, which fetch the requested data. Resolver is a function that generates responses for GraphQL queries and mutations by acting as a GraphQL query handler. It's defined within the GraphQL schema that a particular query will reuse the resolver. Now for this tutorial, we'll be creating backend for a book rental application. Here, we'll have 4 modules. First is authors module, which will store authors info, including IDs of the books that they have published. Next, we have books module, which will store books info. Now, books and authors will have many-to-many relationship. One author can publish multiple books. Similarly, one book can have multiple authors. Now, books will also store rental IDs, with which we'll be able to identify which user rented this book and for how many days. Next, we have users module, which will store customers info. And last, we have rentals module, where we'll store all the book rentals info. Now we can clearly see a graph being created here between these modules. For example, I want to fetch a user's info along with all the books they have rented so far, and also the books info. I can easily do that in a single query using GraphQL. Let's implement this. Alright, let's see this in action. I've created a sample Nest project where we'll be making our changes. Let's start by installing the required packages. First, we'll install GraphQL, which is a JavaScript implementation of our GraphQL specification. It provides the fundamental building blocks for working with GraphQL. Next, we need Nest GraphQL package. This is a package for integrating GraphQL with NestJS. Next, we need Apollo server, which is the core package for implementing a GraphQL server using Apollo server. Next is Nest Apollo package, which provides additional utilities for using Apollo server with NestJS. Next, we need Mongoose and Nest Mongoose package. Now once the packages are installed, we can open app module and import our GraphQL and Mongoose modules. In imports, we can add Mongoose module first and add the for root method. We have to define our connection string first, and then optionally we can define a database name as well. Next, Let's import GraphQL module and add the for root method. This for root method takes few optional properties. First we have is driver, which we can set to Apollo driver. Next, we have playground, which we can set to true. Now this driver properties allows us to choose different GraphQL server implementations. In our case, we are using Apollo driver, which means that Apollo server will be used as underlying GraphQL server implementation. Next we have playground, which is a powerful interface for testing and debugging GraphQL APIs interactively. Now before we talk about other properties, let's first understand the different ways of using GraphQL in NestJS. First, we have code-first approach. In this approach, we use decorators and TypeScript classes to generate the corresponding GraphQL schema. The schema is auto-generated by GraphQL at runtime and is stored in a file. The file path we need to define in this auto-schema file property. The next approach we have is schema-first approach. In schema-first approach, we have to define our GraphQL schema using GraphQL Schema Definition Language, or SDL. Here, we define type paths property, which tells GraphQL where to look for GraphQL schemas in current working directory. Now for this tutorial, we'll be using code-first approach, as this is mostly preferred by developers and has some advantages like type safety and better tooling support over schema-first approach. Now let's open VS Code again and add another property called AutoSchema file. And let's define the path where we want to store all of our schemas. Here, all of the generated schema will be stored in this schema.gql file. Before we dive in, I want to mention that I've created a GitHub repository for this project. The link is provided in video description below. In the repository, I've structured the code into multiple branches for each part of the series. So if you want to focus on specific sections, like authors module, you can check out the authors module branch. Similarly, there's a books module branch for the books section, and so on for the other parts, like users and rentals. If you are looking for the complete code base, feel free to explore the master branch, which contains the entire project. Make sure to check out the repo and feel free to ask any questions in the comments if anything is unclear. Let's get started. Okay, let's start with authors module. Here, I have created this module to save us some time, but I'll walk you through the code step by step and explain each concept in detail. At first, we have author schema. Here, I've created an author class, which has few properties like ID, name, email, and so on. For now, let's ignore this book IDs field because we'll add it later once we have books module. But why do we need schema? In GraphQL, the schema is the blueprint of how data is structured and queried. It defines the shape of our data, the type of queries allowed, and how mutations can be performed. In our case, we use the author schema to define what an author object looks like in both MongoDB and GraphQL. Here, the schema decorator makes the author class a mongoose schema for MongoDB. At the same time, the object type decorator makes it a GraphQL type, allowing us to query or mutate it in GraphQL. Similarly, prop decorator is used by Mongoose. It defines the properties that will be stored in DB. So when we use prop decorator above a class property, we are essentially telling MongoDB to store that field for our document. Also, field decorator comes from GraphQL and used to expose fields in our GraphQL API. It makes these properties available for querying or mutating in the GraphQL schema. Without field decorator, these fields wouldn't be accessible in GraphQL. By combining these two decorators, we can ensure that our data is stored in the DB and is accessible through GraphQL. Also, I've created an author document which represents the actual data structure stored in MongoDB. It's a combination of author class we have defined and the built-in Mongoose document type, which includes methods for interacting with database, like saving, updating, and deleting documents. In short, author document is what we'll be working with when performing CRUD operations in MongoDB from author schema. Below I've defined few input types for creating, updating, or querying authors. These input types help us specify the structure of the data being passed in mutations. Create author input, for example, ensures that when we create new author, we always include name, email, phone, and country. Next, let's see author service. Services handle all the logic in NestJS. The author service, in our case, interacts with database to fetch, create, update, or delete authors. First up, we have our constructor, where we are injecting author model using inject model decorator. This is the Mongoose model for author schema that we defined earlier. It allows us to interact with MongoDB using Mongoose method like find, create, etc. This injected model is the core of our service, as it's used to perform all the database operations we need, like fetching or modifying author data. Without injecting this model, we wouldn't be able to communicate with MongoDB effectively. Now let's quickly go over each method in the service and what they do. First, we have getAllAuthors. This method fetches all authors that match the given params from the database. In case no params provided, by default it will fetch all the authors. In case no authors found, it will throw a not found exception. Otherwise, we'll return the authors. Next, we have find authors by ID. This method finds an author by their ID. If the author doesn't exist, it will throw a not found exception. Otherwise, we'll return the author details. Next, we have find by book ID. This method finds author who have written a particular book. It searches through the book IDs array to find matches. We'll use this method later once we have book module. Next, we have create author. This method creates a new author in the database with the provided input. If the author creation fails, it will throw an HTTP exception. Otherwise, it will return the created author. Next, we have update author. This method updates the existing author details by their ID. It can also add new books to the author's book IDs field. If the update fails, it throws a HTTP exception. Otherwise, it returns the updated author. And last, we have delete author, which deletes the author by their ID from the database and return the deleted author. Next, let's see author resolver. The resolver is what connects our GraphQL API to the business logic in the service. It defines how GraphQL queries and mutations will interact with the data. So I've created an author resolver class, which is decorated with resolver decorator. The resolver decorator marks this class as a GraphQL resolver. In this case, it's specifically resolving queries and mutations for the author type. This decorator essentially tells GraphQL that this class will handle how data for author is fetched or modified. Then in constructor, I've injected author service. This allows the resolver to call methods from the service to handle the actual logic for fetching or modifying the data. Now let's quickly go over the methods and what they do. First, we have getAllAuthors. This query fetches all authors that match the given input params. It returns an array of author object. This method is decorated with query decorator. The query decorator is used to define a GraphQL query and is used to fetch data. Next, we have find authors by ID, which is also a query. This query fetches a specific author by their ID and returns the author. Next, we have create author. Create author is a mutation which creates a new author in the database using the given input params and returns the newly created author object. Mutations are decorated with mutation decorator. These are used to modify data, whether it's creation, updation, or deleting records. Next, we have update author, which updates an author details by their ID and returns the updated author object. And last, we have delete author, which is also a mutation and is used to delete the author by their ID from the database and returns the deleted author. And at last, we have authors module, where we have defined two properties, imports and providers. In imports, I have registered author schema with Mongoose using forFeature method from Mongoose module, which makes it available to service and resolver. Previously, if you remember, in author service, we injected author model. We won't be able to use this model in author service if we don't register author schema in author module. And last, I have added author service and author resolver as our available providers. Now, let's run our application and see our queries and mutations. First, let's open terminal and write npm run start :dev. This will run our application in watch mode. Once our application is started, open Chrome and go to this URL. And this will open our GraphQL Playground. Previously, if you remember, in app module, we set this playground property to true. That's why we are able to open GraphQL Playground. Now this is how we write a query in GraphQL. So at first we define whether we want to write a query or mutation. For query, we write query keyword. For mutation, we'll write mutation here. Next, we define which type of query we want to create. Like in this case, we are creating an author's query. Then we create a params variable and we define the type. Like we want to fetch all the authors and our input type will be find author input. Then we define our actual query, which is authors. Inside it, we define what all variables or what all properties we want to retrieve in response. If we want to retrieve all the fields, we can define all the fields. If we want to, let's say, retrieve only name and email along with ID, so we can just define these three fields and we'll get only these three. For now, let's get all the fields. Then below we have query variables and HTTP headers. In query variables, we have to define the params. Like for now, I'm just setting params to empty object. That means I want to fetch all the available authors. So if I hit this run, I'm able to fetch all the authors. Now if you notice, I'm able to fetch all the fields. Now let's say at front end, I only want the name and email of the authors. I don't want phone and country, nor I want IDs. So I can just define name and email here, and I'll only retrieve name and email from GraphQL API. Now, if in case I want to create a new query, I can click on this plus icon here, and this will open a new tab. And here I can define my another query. Also, if I want to see the docs for this author's query, I can click on this docs here. This will list down all the available queries and mutations we have. Like if I click on authors, this query is to get all the available authors from database. So we can see the type author and what are all available fields we have and their data types. And also we can see what are available params we have based on which we can fetch the authors. Similarly, we have mutations like we have create author. We can see the type and the arguments based on which we can create author. Now, I want to talk about how we interact with the GraphQL API. Initially, we have set the playground property to true in the app module file. This enables GraphQL Playground, which is a useful tool to test out queries and mutations directly in the browser. However, while it's easy to use, there are better options available for a more enhanced experience. A more modern and feature-rich way to interact with GraphQL APIs is through Apollo's Server plugin landing page. It provides an intuitive interface with better documentation, history, and other features that make interacting with APIs smoother. It feels much like GraphQL Playground, but with additional customization options and a more polished UI. To switch from GraphQL Playground to Apollo Server landing page, we'll need to install and configure the required package. Let's head over to VS Code. First, we need to install this package. And then in app module, we have to set our playground property to false. And then we can add a new property called plugins, where we can import this plugin, something like this. By doing this, we replace the basic playground with a more advanced and user-friendly landing page, which enhances the development and testing experience. So moving forward, whenever you run the app, you'll be interacting with Apollo's landing page for all your GraphQL queries and mutations. It'll make your development process more enjoyable and efficient. Let's restart our server and see the Apollo's UI. Now, let's run our app again. I'll open the terminal and I'll run our server in watch mode. Then, once the app is running, open Chrome and hit the same endpoint. This time, instead of opening GraphQL Playground, it'll open Apollo landing page UI. Make sure your internet is on in order to interact with this UI. Now, on the left hand side, under root, we have two root types, query and mutation. Let's interact with the queries first. So just click on the query, and here we can see the list of all the available queries. To interact with the query, just click on this plus icon here, and it will add the query in a new workspace. Now, inside this, we can define what all fields we want to retrieve from GraphQL API response. Let's say we want to retrieve name and email of the authors. Now below, we have this variables tab where we can define the params. By default, we can see GraphQL is complaining that we have incorrect type for this params key. We are expecting an object, so let's define an empty object here. This means that we'll retrieve all the available authors from our database. In order to interact with this, or in order to hit the API, just click on this button here. And now it will retrieve all the authors' name and email from our database. Let's say we want to retrieve country as well for all the authors. So we can just add another field here and hit the button again. And this will retrieve now country as well for all the authors. Now let's say we want to retrieve all the authors where country is USA. So in params, we can define the country property and set it to USA. Now hit this again and we'll get all the authors where country is US. Next, let's click on the root again, and this time let's see mutations. Now if I click mutation, we can see all the available mutations here. Now if I click on this plus icon, we can open a new workspace. And then click on this plus icon to interact with the create author mutation. And then I can just click on this field to return all the fields for the created author. And then we need to define the params here. So if I just click on this params argument, which is of type create author input, we can see these are the 4 fields that we need to define. And these are the types for all these fields. Now next to type, if you notice, we have this exclamation mark. This means that all these 4 fields are required in order to create an author. So let's create all these fields and let's provide the values quickly. And then once we hit this, our author is created. Now, in order to verify, we can just hit the author's query again. Okay, let's update the country to UK. And we can see our author is created. Next, let's work on books module. Let's start with schema first. Similar to author schema, I've created book schema as well. First, we have book document, which is a combination of book schema class and Mongo's inbuilt document. Then I've defined a book class, which has few properties, and this class is decorated with schema and object type decorator as well. For now, let's ignore this rental IDs property because we'll add this later once we have rentals model. Then I've exported this book schema, and at bottom I've defined few input classes. These are input types in GraphQL that specify what fields we expect when querying or mutating data. Each of these input types is marked with input type decorator. Next, let's move on to the book service. At first, we have constructor, where I'm injecting book model using inject model decorator. This gives us access to Mongoose model for book schema. Then I've injected author service to handle interactions between books and authors. After this, I've defined few methods which are quite similar to what we have already defined in author service. Just the only difference is now they are dealing with book model instead of author model. Here, the only change we have is in create book and update book method. Let's go through them. First, let's see the create book method. What it's doing is, it will create a book using provided inputs, and then it will update relevant authors to associate them with this book. So, we have provided author IDs in params, which is of type string array. First, we'll convert these string IDs to object ID format for MongoDB. Then we'll create the book using create method from book model. If in case the book is not created, we'll throw an HTTP exception. Otherwise, for each author associated with the book, their book IDs are updated to reflect the new book, and then we'll return the book. Also, we need to make sure in author schema, we'll uncomment this book IDs field that we have commented previously. Now, let's quickly go through the books module. Here, I've imported Mongoose module to define the schemas for both books and author. Then, I've imported authors module using forward ref. The reason I did that is because in authors module, I've imported books module as well. Now, in NestJS, this will raise a circular dependency issue. So, in order to resolve this, we can use forward ref function, and it ensures that both books module and authors module can reference each other. Now, let's move on to the books resolver. Here, I've created a books resolver class, which is decorated with resolver decorator. Then, in constructor, I've injected two services, book service and author service. Then, I've created few queries and mutations. These are similar to what we have created in authors resolver, so I won't be going through these again. But we have two new things here. First is this names property. Although we have defined it in authors resolver as well, but I forgot to cover that. So I'll cover it here. This name property defines the query name in the GraphQL schema. In this case, books is the query name that clients will use when they want to fetch all the books. By default, the method name is used as query name. But if we want to define a different name, we can use this name property. And the second is this resolve field decorator. The resolve field decorator is used to resolve fields that aren't directly stored within the book object but are instead related to other entities like authors. In this case, the author IDs field in the book model is a reference to the author model, so it requires a special resolver. Let's take an example, but before that, let me start the server. Now once the server is running, I'll head over to Chrome and hit the same endpoint. Under query, we can see book queries as well. Now let me open a new workspace and add the books query. Suppose we want to get all the books and we want only name and genre of that book. Let's add name and genre fields. And in params, let's add an empty object so that we can get all the books. So if we hit the endpoint, we are able to get name and genre of all the books. Now let's say we want author IDs as well. We can get author IDs as well because in book schema, we have added author IDs property. But if we want to get author name as well, we won't be able to get that if we don't resolve this field. So let me comment this code first. If in case we don't resolve this field and we hit the endpoint, see, GraphQL will complain that it's not able to resolve this author IDs field. Initially, GraphQL doesn't know how to resolve these fields. So we have to explicitly tell GraphQL how we want to resolve this field by creating a method and decorating it with resolve field decorator. So if I uncomment this code and I hit save, then let's hit the endpoint again. And now we are able to get author name as well. And not just name, we can get any author field. Let's say we want to get email as well, we can get email. Now let's see how to define these methods. The method name will always be the field that we want to resolve. Like in this case, it's author IDs. The method should be decorated with resolve field decorator with return type. This method will rely on parent decorator to get the parent object, in this case the book, and uses its ID to fetch the corresponding authors through the author service. To wrap up the video, I'll introduce the users and rentals modules. These modules follow the same structure and concepts we have covered with the books and authors modules. The patterns, decorators, and approaches for building services, resolvers, and schemas are very similar, which will make it easier for you to understand. Now, instead of walking through all the code for these modules, I encourage you to visit the GitHub repository linked in the video description. You can check out the complete code for the users and rentals modules there. Take your time to review it, and if you have any questions or run into any issues, feel free to drop a comment below. I'll be more than happy to help clarify things. That's it for this session. Don't forget to like, subscribe, and hit the notification bell so you don't miss the next video in the series.